I'd like to do one more example where we're given a map between groups and we examine the various properties of that map. So in this example, phi is going to be a map from the group of real numbers to the group of real numbers excluding 0, and our map is going to be another common one, the map that takes in as x its input and outputs e to the x. The question is this map a group homomorphism? Is it one-to-one? And is it onto? In order to examine whether or not this function is a group homomorphism, we need to make sure that we understand what the map is and what the operations of our two groups are. Because we're dealing with the real numbers in our domain and we have not excluded 0, our operation must be addition. However, on the right, once we exclude 0 from the real numbers, we must be working with the real numbers under multiplication, or else we wouldn't have an identity element, and 0 creates problems multiplicatively when we're talking about inverses. So our group operation in our domain is addition, and our group operation in the range is multiplication. Remember that I use the word range to denote the set of possible outcomes, and the word image to represent the set of actual outcomes, which may be non-standard. Once we understand the map given here and the operations of our two groups, what we need to do is translate our generic group homomorphism property to the context of this particular problem. Here, we'll be asking if phi of a plus b is equal to phi of a multiplied by phi of b whenever a and b are real numbers. So the first step we've made is to translate from dots and stars to our specific group operations. The next step is to determine what each of these values are equal to based on the map phi. Well, our map phi takes an input and places it in the exponent of the e to the x map. So phi of the quantity a plus b would be equal to e to the quantity a plus b. Again, using rules of exponents on real numbers, we know that this breaks down as e to the a multiplied by e to the b, and e to the a is precisely phi of a according to our map, while e to the b is precisely phi of b according to this mapping. Therefore, this exponential map is in fact a group homomorphism from the real numbers additively to the real numbers multiplicatively. In order to check if this map is one-to-one, we have to take two output values, that is, two values in the image of our phi map that happen to have equal images, and what we're asking is, does this imply that the initial inputs to the function have to be the same? If so, our map is one-to-one or injective, and this is the case. If you envision a Cartesian plane here, and the x maps to e to the x map, it does this exponential growth mechanism that I'm miming with the mouse right here, and that map is easily seen to be one-to-one. However, also visualizing that map, you'll know that negative numbers do not belong to the image. We do not have any values of a and b that we could plug into e to the x in order to get a negative number. And since the real numbers minus 0 include negative numbers as well, we see that this map is not onto. So this is an example of a group homomorphism that happens to be one-to-one, but is not onto, which again is totally acceptable for group homomorphisms. We're just checking about these properties out of curiosity.